So artificial intelligence has given us a new form of map to explore the world. And what I want to do is give you an illustration and an example of how you can use that map. So I want to do that by looking at how we use a traditional map, so a 2D map here. We've got examples of a couple of documents which are related to strikes in Ukraine, and they have coordinates which are a latitude and a longitude, so that's a two-dimensional set of points. And as you zoom out on the map, you'll notice that it groups together these things because they're nearby, they're next to each other. And it does that to help declutter, because as we zoom out further and further, there are more and more points that are being visible on the map. So it makes sense to kind of group them together. And each time it does that, it's finding the center point between the things that it's grouping, and it replaces those items with a single grouped item. So that's something you might have seen on Google Maps or things like that. There are various products that do that. But this idea of grouping based on distance is one that's very important, and we'll see that applied to the AI map. So the AI map is not a 2D map, it's not a 3D map, it's in this case a 1536 dimension map, which sounds crazy, but the idea of having a simple slider for zooming in and out is still there, which makes life much simpler. So let's have a look at what we're talking about here. So what we have is a set of news articles here. We've got about 1.5 million news articles, and we've got the latest 200 news articles here. And you'll notice that for each of them we've got, obviously the text of the article. And what we did is we gave that to an AI, and in return it gave us back a set of coordinates. So this fuzzy blob here is actually a set of numbers which defines that location in this very abstract 1536 dimensional space, which you can think of as being like a big brain, and it's chosen to store things related to Florida elections and Trump and so on in that location. And nearby it keeps other related articles that are talking about similar things in that area. And it will have a separate location for torpedo bats, whatever the hell they are. So each of these gets a unique kind of location in the brain, and you can measure the distance between things that are stored in there, and the things that are near each other are very similar in subject matter, and the things that are far away are very dissimilar. Now, the point of all that is that we can do the same sort of grouping that we saw on the map when we zoomed in. So here are the 200 articles, and if I zoom all the way out, we end up with one cluster of 200 results, much like this one. When we zoom all the way out, we just get one cluster. And if we zoom all the way in, then we end up with 200 individual points or individual documents. But somewhere in between is where we get something useful. And we can see, for example, here there's a grouping of 9 documents all talking about Trump and tariffs. And we have a grouping here of 3 documents talking about Elon Musk stepping down from the Trump administration. And in each case, what we have is a coordinate which represents the center point, so the middle of these 3 nearby documents. So it's calculated, what the average of these is, and it's got a center point that we can use as a query. So if we're interested in the fact that Elon Musk might be stepping down from the US government, we can pick that up and use that as a query. And now we have the 71 nearest documents which are similar and talking about Musk stepping down, or perhaps not stepping down, from the government. And the further we go down the list, the further away these coordinates are. So I've coloured these bars based on how far away they are. So the more coloured in bits you've got, the closer they are. And as we go down the list, we get things that are a little bit further. So here we've just got Trump holding a cabinet meeting with Elon Musk in attendance, so nothing about him stepping down necessarily. So what we can choose to do is to say, well, let's set our search radius. So if we look for things that are very similar, then we're looking for a short distance away from that centre point, and we have things which are very strongly related to that subject. So this changes how we might actually talk to search engines. So rather than talking to search engines by saying search for a particular keyword or having to try and think about what are the right terms to use, do we use the word Doge, do we use US government, do we use Musk, we can actually just pick up these clusters and group them and say, I'm interested in this subject, tell me more about that, and use the coordinates directly. That fundamentally changes how we talk to a search engine and how we can overcome the issues of finding the right keywords to look for things and finding things which are similar. And it's similar to the way you might be used to navigating a map and zooming in and having a look at things nearby. That's the way to think of it, even though it is a very abstract concept and we're talking about 1,536 dimensions. It doesn't matter really when you can think of it just in terms of proximity and having things which are either close or very far away.